Now I am going to take the question number 11. Two blocks of masses m1 and m2 are kept on a rough inclined plane. Coefficient of friction between two blocks with planes are mu1 and mu2 respectively. Mu1 is greater than mu2. Blocks will start sliding down the incline at an angle theta. So here we are saying that mu1 is greater than mu2. यहाँ पर mu1 का वैल्यू mu2 से ज्यादा है. इसका मतलब mu1 जिसका कोएफिशिएंट ऑफ फ्रिक्शन है उसका फ्रिक्शनल फोर्स सेकंड से ज्यादा होगा, यानी F1 इज ग्रेटर देन F2. फ्रिक्शन फोर्स ऑन M1 block will have the more value as compared to M2 block. By this observation we can say both blocks will start sliding together. क्योंकि जो F1 पर फ्रिक्शन फोर्स लग रहा है वो M2 ब्लॉक से ज्यादा है, तो दोनों ब्लॉक साथ में मूव करेंगे, तो दे विल मूव टुगेदर एंड द डायरेक्शन ऑफ फ्रिक्शन फोर्स इज दिस, एंड along with the direction of motion there will be the component of weight is m1 plus m2 into g sin theta because they are moving together. Okay, so when m1 plus m2 into g sin theta is the force acting downward direction, and that is equal to, because question says block will start sliding down, and that is possible only if this is equal to the total frictional force, right? So I am going to write the mathematical calculation m1 plus m2 into g sin theta, and force of friction is given by mu1 m1 g cos theta. I would repeat, friction force is calculated by mu n, and n is equal to for m1 g cos theta, and for m2 g cos theta. So we'll write mu1 m1 g cos theta plus mu2 m2 g cos theta. So if I take g as a common from both sides, so we can cancel them. So we'll write m1 plus m2 sin theta, that is equal mu1 m1 cos theta mu2 m2 cos theta, because small g will cancel out, तो कैंसिल हो गया. अब आप देख सकते हो कि अगर मैं cos थीटा को कॉमन लूं और उसको राइट से लेफ्ट में ट्रांसफर करूं तो विल गेट sin थीटा अपॉन cos थीटा. So that will give you tan theta. So tan theta is equal to mu1 m1 plus mu2 m2 divided by this m1 plus m2. m1 plus m2. So this is the value of tan theta. So on behalf of that we can say my option number 2 is correct. So first I am going to read the question number 12. A gun of mass m fires a bullet of mass m with speed v related to barrel of the gun. This is very important line, so you have to very careful this. Which is inclined at an angle of 60. Diagram में show हो रहा है with the horizontal. The gun is placed over a smooth horizontal surface. Is smooth, there is no friction. The recoil speed of gun will be. So this question we can solve by using law of conservation of linear momentum. First I will resolve the component of this. So we'll write v cos 60 and here v sin 60. If I consider this is u, recoil speed. So now if I go for the law of conservation of linear momentum, then before firing there is no momentum, so we'll write mv cos 60 plus mu, that plus mu, that is equal to 0. So there is some new term. This is V is the component of velocity along with the horizontal direction, that is V cos theta. So we will take the velocity of bullet by this component, and mass of the bullet is m, so this is the linear momentum of the bullet. But question says with speed v related to the barrel of the gun. That's why I am going to take this mu, because the direction will be opposite in terms of relative velocity. You can do this, and this is the linear momentum of the bullet, and I need this value of u. मुझे ये u चाहिए. So we can write this. If I take small u as a common, so we'll get small m plus capital M. Capital M is the mass of the gun, small m is the mass of bullet, and that is equal to minus mv. The value of cos 60 is 1 by 2. So when I go for the u, because u is the recoil speed of the gun, so u is given by minus mb upon 2 times of small m plus capital M. So on behalf of that, we can say my option number 3rd is correct. So first I am going to read the question number 13. A small block of mass n is kept on a rough inclined surface of inclination theta. Okay, so this is inclination with theta. Fixed an elevator. The elevator goes up with a uniform velocity v. Uniform velocity, so there is no acceleration. And the block does not slide on the wedge. This block, this is the position of the block, and it will not slide. The work done by the normal contact force between the block and the wedge in time t. So first I am going to make the free body diagram, or I am going to resolve the forces. So we know mg will act toward the center of earth, and if I resolve the component of the weight, then we'll get there is a component of weight mg cos theta, because theta is there. And if I want to take normal force along with the direction of this weight, so this angle will be theta, and this is the component of normal force n cos theta, and this is the velocity as per the question. ये एक सिचुएशन है, और मुझे चाहिए work done by the normal contact force between the block and the wedge in time t. So as block is at rest with respect to the lift, यहाँ पे दिया जा रहा है कि ब्लॉक लिफ्ट के रेस्पेक्ट में रेस्ट में है, सो वी विल टेक नॉर्मल फोर्स इज इक्वल टू mg cos theta. There is no confusion, because block is at rest with respect to the lift. So now if I go for the displacement of block with respect to the ground, so that is calculated by s is equal to vt, speed into time. Vertically upward, I would like to mention that vertically upward, this is, and this is my relation number 2. Work done by normal contact force is given by work normal force into displacement into cos theta. This is the formula, and the value of normal force is mg cos theta. Displacement s is equal to vt as per my relation number 2, and cos theta is there. So when you will solve, we'll get mg vt cos square theta. So this is work done by the normal contact force between the block and the wedge in time t. So my option number 2 is correct. So now I am going to take the question number 14. Two blocks of mass 4 kg and 10 kg are connected with a massless string and a massless spring in between them. A string goes over a massless and frictionless pulley as shown in figure. Initially the spring is unstretched when 4 kg block is released from rest. minimum normal contact force between 10 kg and the surface in contact with it will be. So the most important thing of this question, I want to calculate minimum normal contact force between 10 kg and surface. And minimum normal contact force is possible when force applied by the spring is maximum. So now I am going to make the free body diagram. This is, if I consider this is minimum normal force, this is the direction of force applied by the spring, that is given by kx, and x will be the maximum. mg 100 Newton will act in downward direction. So now if I go for work energy theorem, according to this theorem, work done by all forces is equal to change in kinetic energy. If I talk about change in kinetic energy, then initially block was at rest, and finally when spring force is maximum, then it will gain the rest position. ये फिर से rest में आएगा, so there is no confusion regarding change in kinetic energy will be 0. And now I am going to calculate the work done. Two type of work is here. First work is done by the weight mg into x, if x is the displacement, and work by the spring is half kx square. Small m will represent maximum elongation or compression, and that is equal to 0. Why we are going to take this negative sign? Because you know force applied by the spring is opposite to the direction of elongation. So if I go mg x, that is equal to half kx square, and m, as I said, m is represent maximum compression or elongation आप represent करते हो. So now we are going to place the value. Mass m is 4, g is 10, and x maximum 1 by 2 k x maximum with square. So x maximum cancel, and we have 40 on left hand side. When I will transfer 2 from left to right, so we'll get 80 Newton, and this is the value of kx. X is the maximum, and this is my relation number 1. So now I am going to use the second law of motion. So you are saying that हम लोग ये देख रहे हैं कि the direction of minimum normal force and spring force kx are in same direction, and this component of weight will act in downward, and that is equal to 0. So if I want to calculate only minimum normal contact force, that will give you mg minus kx. As you know, mg is 100 Newton and kx is 80 Newton. So that will give you 20 Newton. So my option number 2 is correct. Question number 15. In the arrangement shown in figure, the relation between acceleration of block M1 and M2. So you can solve this question by using a trick. Suppose if I take a single pulley and a string यहाँ पर fix है. If I use a force F, if I consider tension T is there, then tension T is there because ये fix है. इस स्ट्रिंग को लेंथ आप इंक्रीज नहीं कर सकते. इसका मतलब ये है कि अगर राइट साइड में टेंशन टी है तो लेफ्ट हैंड साइड में भी टेंशन टी होगा. सो इफ आई वांट टू कैलकुलेट द फाइनल टेंशन, सो विल सी द डायग्राम. दिस इज टी, सो विल गेट 2t is here. Similarly, if I take one more example regarding this, suppose this is the same diagram. यहाँ पर मैंने इसको फिक्स किया, and this is the another pulley. ये भी फिक्स है और यहाँ पर फोर्स F. So we'll write T on the basis of diagram number 1. This is 2T, this is 2T. So we'll write here 4T. So we can calculate the net tension is 4T. Similarly, if I go on that diagram, so we'll write here, अगर मैं इसी का यूज करूं तो अगर ये T है तो यहाँ पर भी T होगा, and that will give you 2T. ये भी 2T होगा. So if I go for final, that is 4T. So now we can make this diagram like this. ये एक्सेलरेशन a2 अपवर्ड डायरेक्शन में, ये डाउनवर्ड डायरेक्शन में. अगर मैं m1 या m2 को डिस्प्लेस करूं तो इसका जो डिस्प्लेसमेंट है वो m2 के कंपैरिजन में 3 टाइम्स होगा, क्योंकि you are saying that 2t and tt are acting in same direction, so we'll write 2t plus t, and on the right hand side you are saying only t. So if I take a1 is here and a2 is here, आप सिंपली देख सकते हो कि m1 को अगर मैंने डिस्प्लेस किया, m1 m2 में जो डिस्प्लेसमेंट है वो 3 टाइम्स होगा, क्योंकि यहाँ पे 2t है और t है, दोनों का डायरेक्शन सेम है. और राइट हैंड साइड में m2 ब्लॉक पर देयर इज ओनली 1t, सो विल राइट 3t into a1 and t a2. tt will cancel, so we can find a relation 3a1 is equal to a2. So on behalf of that, we can say my option number 4 is correct.